Hello everybody, part 3, notes for A9, ABS, continuing with example 4 here. And we are going to use the same exact process that I've already been talking about with the previous 3 examples, I think one of which you may be able to see the bottom of up here somewhere. It's up here, there it is. So same thing, we need to solve for y, simplify the left side if we can, or the right side if we can. And I keep saying simplify the right side because most of the time the y's will end up being on the left. So in this case we have 2 times y. It is clear that y is not isolated, so we should divide all terms by 2 to isolate the y. So it'll look something like this, divided by 2, divided by 2, divided by 2. And that will give you y equals 3 over 2x minus 4 divided by 2 is 2. Now that we have solved for y, I can assure you there's no distributions or terms to collect over here on the right side. The next step was pick x values that make sense. And up until this point, I've been telling you, hey, just pick -1, 0, and 1. Well, that's not going to work here so well, and I know a lot of you out there do not like working with fractions, and in fact, fractions are hard to graph on a coordinate plane. So what we can do is we can pick x values that make our lives easy. And what we need to look at when we are picking x values when we have a rational coefficient, aka a fraction multiplied to x, is what number is in the denominator. And in this case it's 2. Once you realize what number is in the denominator of the coefficient of x, you can just go through and pick negative that number in the denominator, 0, and positive that number that's in the denominator. Why would you do that? Well, I'm going to start out with the positive one. So let's get the blue. There we go. So I'm going to substitute 2 in for x, and you'll see what happens here. 3 over 2 minus 2 equals y. So when we multiply 3/2 times 2, all we're doing here is canceling the 2's. They reduce. The 2 is in the numerator of a fraction. You could multiply the 3 times the 2 and get 6. Multiply the 2 times the 1 in the bottom to get 2. 6 over 2 is 3. Otherwise, you can just reduce the 2's and see that your answer will be 3 divided by 1. So y will equal 3 minus 2, and y will equal 1. So when x is 2, y is 1. And we pick 2 because it's divisible by 2. Honestly, you could pick 4 or 6 or 8 or any number that's divisible by 2 and it will work. We usually just pick the positive and negative of the number that's in the denominator and 0. Because when you substitute 0 in for x, 3/2 times 0 is just 0. 0 minus 2 is just minus 2. Like, we can figure that one out pretty easily. And then when you substitute -2 in for x, you can reduce the 2's again, but now you have a 3 times a -1. So that would be -3 minus 2 is -5. So again, we picked x values that make sense because they will divide nicely by this number. We found the y values that are paired with those x values. Now we have ordered pairs. Then we just plot those ordered pairs. -2, -5 is way down here. 0, -2 is right there. And 2, 1 is right there. Connect, extend, draw your arrows, and label it if you want to. There's my connect, extend, arrows, and label there. And one thing I'm going to point out is I label with the original equation that's here. And I do that just in case I made a mistake in my math here I don't want to use a mistake to label a line. I want to use what was given to me to label this line. All right, next example. All right, example 5, pretty straightforward. We can see already that the y is solved for. There's nothing to simplify on the other side from y. There's no fraction being multiplied to x, so we can just pick the normal -1, 0, 1. We can substitute those numbers in for x. -1 times -5 is a +5. 0 times -5 is 0. 1 times -5 is -5. We can plot those points over here. -1, 5 is way up here. 0, 0 is right here. 1, -5 is over here. I can snap my fingers, and I have my line there. That one was pretty straightforward. I think the only thing that may have given you a trip up is if you notice the 0, 0. But you guys out there in my classes already understand where 0, 0 is. This line passes through the origin. Example 6. Now, example 6, finally we get into something that looks like math, and this makes me so happy. So the first step we need to do here is solve for y. So that means this term here, I need to move to the other side of the equation. Actually, how would I want to say this? This term here, I need to get rid of it on the left side of the equation. So what I'm going to do is I will subtract 8x to make sure that that zeroes out. But on the other side, that also means I have to subtract 8x, and I'm going to do that right in front of the 4. The equation will look something like this. 4y equals -8x plus 4. All right. The next step here, in order to isolate y, we have to divide by 4, divide by 4, divide by 4. Cool. So we will have y equals -8 divided by 4 is -2 x's, and +4 divided by 4 means +1. So this line is pretty easy to graph. Pause the video, graph it yourself. I'll come back in 5 seconds so you can see the solution. Here's my solution. I can take these x values, substitute each one in for x, and find an associated y value to pair up with it. So if I take -1 times -2 is a +2. +2 plus 1 means y equals 3. And you can do the same thing with the 0 and the -1. Plot your points. Again, we're picking 3, so we can make sure that you're doing all of these calculations for y correctly. It looks like those 3 points all land on the same line. So since they all land on the same line, we can draw the line through those, label it. Again, the labeling is optional. You don't have to do that. But it may help you a little bit later when we get into linear programming. All right. One more example for this slide. I'm actually going to give you another chance to pause the video, do this one front to back. Solve for y, pick x values that make sense, find the y values paired up with those x's, and then when you get those ordered pairs, plot them, connect them, extend past those ordered pairs, and put your arrows on it. I'll be back in 5 seconds. All right. Here is the solution for this entire example 7, walking through step by step. The first thing that you always need to do is make sure that you solve for y. So here I am. I've got an x term on the same side of the equation as the y term. So I subtract 3x from both sides, and I'm left with a -6y because that term was negative to begin with. That negative is still there. Equals -3x, because I subtracted it from both sides, zeroed out over here and reduced away, plus 18. From there, we have to isolate the y. That means you have to divide by -6 because any number divided by itself reduces to 1. So that is a 1y. On the other side of the equation, -3 divided by -6, you can reduce the 3 and 6 by a 3, and you'll be left with a 1 over 2, and negative divided by negative is positive. The last term, 18 divided by -6, since the signs are opposite, you'll have a negative. 18 divided by 6 is 3. You'll notice this leaves you with a fraction, 1/2, so whatever number is in the denominator is what you use for your x's. One positive number from the denominator, one negative number from the denominator, and 0 in between them. Then you just substitute those values back in for x, find the y's associated with those x's, plot those points, connect those points, extend past those points, put on your arrows, and labeling is always a nice touch. Cool, well, I hope you did well with that example. I've got one more slide. I know I'm going a little long in this video, but the next slide we will be talking about special lines, and it should go pretty quickly. This is the final slide for assignment 9 notes, I promise. On this slide, as I mentioned, we're talking about special lines here. And special lines are special because they only have one variable, as you can see here with example 8 and example 9. All right, so how do you graph these special lines? Well, it takes some of the process that you already know from graphing the non-special lines. And in that we need to solve for the variable. We're not necessarily solving for y, we could be solving for x here. So we have that, and then we graph it. And it's pretty simple to be graphing these lines. So let me see here. The first example, example 8, we have to check really quick. Is the equation solved for the variable? And yes, you can see here the variable is isolated. There's nothing multiplied or any other terms on this side of the equation with the variable. It's just x equals 7. So here's how we do this. You find this number, 7, on this axis, the x-axis. All right, so there it is. There is 7 on the x-axis. From there, all you are going to have to remember is that x lines are vertical. So from here, you can just draw on your line like this. And that's it, you're done. On the other hand, you can have a y equals line, just the y variable, but it's the same idea. You find this number on this axis. So find -3 on the y-axis, which is right there. And you have to just remember that y lines are horizontal. So from here, you can just draw in a nice horizontal line. Pretend it's perfect. I'm not using the ruler on these. I'm not cheating. And that's it. That is how you graph special lines. X lines are vertical, Y lines are horizontal. There's more explanation that I can give to this, but I will put that in a separate video in the description below. So we take a look at example 10 and 11. You'll notice that the variables are not isolated. Like here we have -7y equals 14. So we would have to divide by -7 to get the equation y equals -2. So again, you just find -2, this number, on this axis. So -2 on the y-axis, and y lines are horizontal. And there it is. And then finally, you may have to do a little more work, like adding 10 here on both sides of the equation to reduce that -10. So you have 2x equals 10, and then if you divide both sides by 2, you would get x equals 5. So you have to find this number on this axis. Find the 5 on the x-axis, and x lines are vertical. All right, that's it. That concludes the notes for assignment 9. I very, very much hope that this makes sense for everyone out there, and I wish you luck.